Okay, so as you can hear, my child's playing Fortnite, and he just got a mystical assault rifle. I asked the moose to be quiet for a minute. Please, Mr. Moose. Thank you. So we've got geometric series to look at today. Geometric series, again, the difference between a sequence and a series is that you're looking at adding up each one of these values as you go through. You're still going to figure out where you have a common rate as it pertains to the problem itself, and you go from there. So just like everything else, it has a formula. This one, the sum of however many we're looking for, is going to be the first term. And then this part looks a little weird. 1 minus the rate to the nth over 1 minus r. Okay? So again, as we go through these things, we have to first identify what our first term is. Well, our first term is easy. It's 1. Our rate, well, between each one of these values, you'll notice you're just multiplying each one of them by 5. So your rate is going to be equal to 5. Excuse me, 1 second. Mr. Moose, I need you to not make any noise right now, please. Thank you. So we have our rate as 5. So we just put it all together. So the rule here, the sum, will be our first term of 1. 1 minus 5 to the n over 1 minus 5. And that's what the generic rule would look like. Now, for example, if I wanted to find the sum of the first 10 terms, that means the n value that I'm looking for here is going to be 10. So again, I go back to my generic rule that we just figured out, and now we know what our n value is. So we have 1 times the 1 minus 5 to the 10th power over 1 minus 5. Again, this works out very easily to put it into the calculator. Moose, 1 parentheses, fraction bar, alpha y equals 1 minus 5 to the 10th power over 1 minus 5. Close the parentheses. And the sum of the first 10 of these would be 2441406. 2,441,406. Pretty straightforward. Okay. Make sure you have all of your formulas written out in one piece of paper so it's easier to find them. And the second part of this type of problem would be find the sum, or find the value of n so that the sum of them added up to equal 3906. Now, we go back to what we had a second ago. We had our rule was our first term, and it was 1 minus 5 to the nth power over 1 minus 5. Now we're trying to figure out what is the n value that gives you a sum of 3,906. So we know that 3,906 has to equal 1 times the parentheses 1 minus 5 to the nth power over, I'm just going to write negative 4 here because it's a little bit cleaner. Okay. Now, since our first term here was 1, it doesn't really have anything to do with the problem here, so I could divide it out by 1 and it'd be fine. But what I'm going to do first here is I'm going to multiply both sides by negative 4 to get rid of the denominator here. So, take our 3906 times the negative 4, and I get negative 15,624 equals 1 minus 5 to the nth power. Now, remember, this value of 1 here, since it was just 1, I divided out. If this was a 3, I'd divide both sides by 3, and so on and so on. No big deal. Now, I need to solve for n, but since this value is negative, I'm going to add 5 to the nth power over to the other side, and then I'm going to add this guy over that way as well. So I have 5 to the nth is 1 plus 15,624. So you wind up with 5 to the nth power is 15,625. Now remember, this means 5 to what power is 15,625. So how do you solve for exponents? We have to log. So we have to do a log base 5 of 5 to the n is log base 5 of 15,625. Since these two bases are the same, that drops the n value here. And now to do the logarithm part, remember it was alpha window 5. Alpha window 5 allows you to get to your log base. So it's log base 5 of 15,625 and hit enter. You add 6 of those up in that sequence, and you'd get 15,625. There you are with geometric. Hope all is well, and we'll talk to you guys later.